This video will be on section 6.1, function direction and extreme values. The three topics in this section. The first one is function direction, and that's going to be talking about when a function is increasing or decreasing. The second section is on something called extreme values. That's where we will have what's called maximum or a minimum of a function. And then the last thing is the only graphing calculator question that requires a graphing calculator in the class. And there will be a handout along with the video that's already in the homework problem for this. So I won't go over this specifically in here because there might be a wide variety of graphing calculators. And you should watch the video in the homework on how to do this. But I can kind of go through the idea when we get there in the last couple of minutes if you're not comfortable using a graphing calculator. All right, so the first thing is function direction. Typically, we only talk about increasing or decreasing, but we'll have the constant as well. So the first thing, a function is increasing if as the graph moves to the right. So this is going to be important. Always think about the way we read from left to right. That's the way we read graphs as well. The graph goes up. So if the graph is moving up as we move to the right, we say it's increasing. Then decreasing is just the opposite. We're always going to be moving to the right, but the graph goes down. And then the last one that we don't see too often, but it's good to know what happens if the graph isn't moving up or down. We call it constant. So a function is constant if, as the graph moves to the right, the graph is horizontal. It's neither moving up nor down. In fact, it's going to look like just a horizontal line, because that's the only way it can't move up or down. All right, so what we'll have a couple of questions just looking at graphs, and I'll say for the following, give the intervals on which the graph is increasing, decreasing, and constant. Also give the domain and range of the function. Just good to practice that every now and then. And what I like to do, I just like to start with and kind of go in order of the three, but you can also look at each section of the graph. But let me keep this in view. So what I'm going to find is and highlight on the graph, this first graph here is where the function is increasing first. But what I want to think about is as I move to the right, as I'm riding along this graph, you can kind of think about just walking along it or something. Where am I going up? And I'm going up on this section over here at the left. In the middle part, I'm not moving up or down. The right part, I'm moving down. The left part, I'm moving up. So it's increasing here. And we want to write the interval that it's increasing on. Now we've seen graphs before, so we know if the graph doesn't have a solid circle or something, that means it goes forever. That means it's going to be increasing forever, because we're going to start, way down here and move up, 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 up. We have to assume it includes, it does the same pattern the whole time. All right, so I'm just writing that in. It's increasing all the way from the left. The way we write all the way from the left, we do the x values. This is what's important. For our interval, we are increasing from negative infinity up, 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 until we get to the x value here of -2. All right, so this graph is increasing from negative infinity to -2, the x values. And one thing that's going to be true for increasing, decreasing, and constant is that you're not ever going to use a bracket, you will always use parentheses. The reason for that is when it changes from increasing to decreasing or something, you have to technically include both, but you can't include both. Can't be doing both at the same time, so you just use parentheses, don't include it. And so make sure you only use parentheses, and then my added comment again, increasing, decreasing, and constant will only involve x values. All right, so decreasing, okay, I just like to go in order, but you can look at each section and go from there. Decreasing is as we move to the right, where are we moving down? And that's going to be on the right side over here. And once again, this is like the left side. We have to assume it's going to decrease as we keep moving to the right. So it starts decreasing at 4, and it's decreasing forever, all the way to the left, or all the way to the right to infinity. Right, and now where is the graph constant? Well, that's just where it's level, but if you go in order, it's got to be everywhere else that you didn't include increasing or decreasing. And it's right here, this middle section. Constant is where it's not moving up or down, it's just flat. And it's constant from -2 to -4, or +4. But once again, x values, parentheses only. All right, and then the last thing, this is just a reminder, kind of always good to practice old things. If, we're not going to do them a lot, but they will be on the final, so it's good to remember how to make sure you can see the domain and range. But the domain here is all real numbers because we can move all the way to the left, moving all the way to the right, and there's no stopping points. Now the range, the bottom of the graph, it goes down to -infinity. And it goes up until the top here, which is at 3, -3. And remember, domain and range, we can use brackets all we need to, and this one is a bracket because -3 is included. All right, the parentheses only is only a rule for increasing, decreasing, and constant. Right. So the next question is just the same directions. Our graph looks a little different. Right, so we have a graph that looks like this. We have this red dashed vertical line. If you don't know the name of it yet, that's okay. We'll talk about it later in the class. You don't really need to know the name of it now, but I'm just going to point it out. This is called a vertical asymptote. But the reason why I just want to go ahead and point it out now is the graphs never touch vertical asymptotes. Right, so if you're not familiar with them, that's all you really need to know right now. All right, the first question, where is the graph increasing? Well, kind of think about, looking at the whole thing. This is less of a section and just really more of just looking at the graph. It's increasing. Once we get down to the bottom here, it's increasing until we get to the top up here. So it's increasing right along here. Then it starts going down again, so it's decreasing. Once we hop over the vertical asymptote, you can see that although we don't know what's going on down here, what's going to happen is since the graph never touches it, it's just going to get really close to it. So let me kind of draw in what this graph would look like if it was extended down. They would just keep going down, down, down on both sides like this, but never touch. So it's going to keep looking like that. And then it's also, you can see it would also be increasing over here. And we want to write both these intervals. Remember, only parentheses per increasing and decreasing. For this first one, little section here, we're going from -1, x is -1, to x is 2. Since we have more than one interval, we use our union. And then we're increasing right after 5. So you put a parentheses anyway, because it's not included at 5. And then it's increasing forever. We can tell that it's flattening out, but we have to assume it's still increasing. Right, we would have to see that it starts going down again or something to assume it's not increasing anymore, and we don't see that. Now, where is it decreasing? Looks like it's decreasing everywhere else. On the left side over here, it's definitely moving down as we move to the right. And like above, it's going to be decreasing starting at negative infinity, x is negative infinity, because it's going to keep falling like this. And it's also decreasing in the middle part here up until we get to the vertical asymptote. And so we have two intervals again. The one on the left starts at negative infinity, x is negative infinity, all the way up until we get to -1, parentheses, union, because we have another interval, and then it starts decreasing again at 2, and it's going to decrease until we get to 5. And you'll notice here it's not constant anywhere. All right, we used all the everywhere for increasing and decreasing. A lot of graphs that you'll deal with won't be constant anywhere. Some will, just to test you on that, but this one's not constant anywhere. And then what is the domain and range? Well, the domain, the x values that we can include are all of them except 5, because we're not on 5. We're skipping over 5. All right, so the way we write that, we have our parentheses starting from the left, because we can start at a infinity, going all the way, the x values go all the way up until 5 before we have a break in our graph. We're not including 5, so it gets a parentheses, union, and then we're also starting up again at 5, not including 5, and it's going to infinity. And that's exactly what this domain says. We start all the way to the left, go up until we get to 5, but don't include 5, then include everything after 5 to infinity. Now the range here, you can see just completely ignoring the right part here, the left part, the bottom goes down to negative infinity, so we start at negative infinity. But the y values, if you're just looking to the left here, they go up to positive infinity, and there's no breaks in the graph. So the domain or range is all real numbers. It doesn't really matter what's happening to the right if the left already includes all real numbers. All right, so the next one is just really to reiterate that you always use parentheses for increasing and decreasing. This one also says, so this one says, give the intervals of the function that is increasing, decreasing, or constant. Also state the domain of the function. So this one's not asking for the range. We won't have to worry about that. We need where it's increasing, decreasing, and constant. All right. So increasing, we're increasing only on the left part here, right? This is the only part as we move to the right, it goes up. The rest are either moving down or not moving up. And what is that interval it's increasing on? Don't let the filled in circles, open circles business fool you. It always has to be parentheses. So it's -9 until -4. We can't be increasing at the ends because there's nothing to the left of it. It's not moving up or down. At -9, we're just starting here. It's not moving up or down at -4, we're just starting here. Okay, so you always have to use parentheses. There are no tricks. Decreasing, where is this graph decreasing? Well, on the second interval here, it's flat, so that's going to be constant. And then on the third part here, we're decreasing at the start of it. And the x values here, they start at 2 and end at 5. Once again, just use parentheses for increasing, decreasing, and constant. I can't say that enough. And then where is it constant? Well, it's going to be constant everywhere else, everywhere that it's a horizontal line. So in the second part here, and the last part here. So the second part here, we've got starting at -4 going to x equals 0 because we're at the y-axis. More than one interval, we get a union. And then the last one here, we're starting at x equals 5 and going until x equals 8. Once again, just use parentheses for all of them. And then the last part is what is the domain? This is where the open and closed circles do matter. The domain starts at -9, starting all the way to the left. Now this one can be a little confusing at first because you see it has an open circle at -4 and you want to put a parentheses at -4, but we also have a closed circle at -4 above. That means we're not actually stopping at -4, we're just jumping to this new piece. So let me go ahead and write that in. Right, domain and range still matters, whether it's open or closed circle or not. Oops, I accidentally wrote a parentheses here. That should be a bracket at -9 because it's a filled in circle. And like I said, we're really just jumping from here to here. We're not stopping. If they were both open circles, we would have to stop. But we have a closed circle up here, so we go until 0. And that's a filled in circle. That gets a bracket. And we have another little segment here. So we've got union. And then we start back at x equals 2 with a filled in circle. So we got 2 with a bracket. And we're going to the right until we get to 8. And 8 also has a filled in circle. So that gets a bracket as well. Right. So like I said, do not make a break at -4 because of the filled in circle. Right? But as far as increasing, decreasing constant, they can't really be any different than what we've done. The main thing is always use parentheses for them. If you ever use a bracket for increasing, decreasing, or constant, you will get it wrong. There's not an example that exists where that would be correct. Right, so the last thing here goes very much along with what our increasing and decreasing stuff is. They're called extreme values, local maximums and minimums, are the words you might see in the homework. You might also see it called just a maximum or minimum or a relative maximum or minimum. They all mean the same thing. You're just really looking for the word maximum or minimum. All right, so I'll kind of define each, and then I'll go back to a previous graph just so you can see it. We say a function f has a maximum, sometimes called a relative or local maximum, if it's at the top of the hill. So the way to think about it is, we go up here. Right here, in this example, is at the top of a hill. But while we didn't answer the question back here, we would say there's a maximum right here at the top of this hill. Right? Everything right around it is below it, to the left and to the right. The way maximum and minimums work is it's just what's right around it, meaning, what's going on way over here or way over here doesn't matter. It's just the top of the hill. And I'll go ahead and mention that the minimums are where you're at, kind of like the bottom of the valley, which would be right here at -1, comma -4. Right, a minimum would be right here in this example because everywhere around it is going to be above. But also just think about it being the bottom of a valley or something. Now, if we go up to infinity or down to -infinity, like we do around the asymptotes or over here, there is not ever a maximum or minimum there. So you have to be able to see the mountain or the valley. Right, and you can see that's exactly what I have written for minimum. Now, really, this goes along with where the graph is increasing or decreasing, but it's honestly usually a lot easier to just deal with problems just dealing with maximum and minimums. So I only have one example here because they'll all look exactly like this. There might not be as many points, but they'll all look exactly like this. It says consider the function in the graph to the right. It has a lot of parts to it, but the first one says the function has a relative maximum of blank at x equals blank. The next one says minimum. Then where is it increasing? Where is it decreasing? What is the domain? And what is the range? Right, so really before we could have already done the bottom 4. And now the new parts are the top 2. Right, so once again, you don't really need to worry too much about the relative. It could say local. It might only have the word maximum here. Maximum, what's important. And we want to think of the top of the mountain or hill, whatever. And that's going to be right here where this filled in circle is. So we have a maximum right here. Right. Now you'll notice that the maximum, and you probably already noticed that the minimum is right here, the bottom of the valley. Usually they make these circles filled in on the graph so you can easily see where they are. But if you don't know what they are, you don't know what you're looking for, then it's not very helpful. All right, so when it comes to maximum minimums, we care about the x and the y value. I'm going to write down the coordinates of this. X is -7 and y is -1. Just to make it clear that we're talking about x-y pair here, not an interval. And when we fill this out, it says the function has a relative maximum of blank at x equals blank. Well, what goes in the first one is the y value. Right? The quantity, what is the actual maximum? It's -1. at x equals blank, the x value where it occurs at is -7. So when it comes to maximums and minimums, honestly, most of the time the y value is more important, but usually we do both x and y together. The function has a relative minimum. Once again, we only care about the minimum of blank at x equals blank. So the minimum is right here. And the xy coordinates here, x, it's on the y-axis, so x is 0, and y is -8. Right, so the y value, the relative minimum, is at -8, and the x value is at x equals 0. But that's really all the new stuff. So, we still want to be able to make sure we can answer the rest, even though we just did it. But where is the function increasing? Well, it's increasing to the left. Now we can kind of use our maximum and minimums as reference points. It's increasing to the left of the maximum. And then it's also increasing to the right of the minimum. It's where we're moving up as we move to the right. And so our answer here, we know this goes back to -infinity, the x values, goes all the way up to -7, parentheses, union, starts increasing again at 0, and it's increasing forever to infinity. Where is the function decreasing? Well, it's decreasing between the maximum and minimum. That's just special to this problem. If this graph could be flipped around, it might be increasing between. If you have a maximum minimum, you just have to look at the picture. Don't memorize what I said exactly. So this one just happens to be decreasing between the maximum and minimum. And the x value here, it starts at -7, and it's going to x equals 0. And now the last thing, the domain and range. The domain, there's no breaks in the graph. We can start all the way to the left and go all the way to the right. So -infinity to infinity. The range is also -infinity to infinity because we go all the way down at the left side and we go all the way up at the right side. So kind of a perfect picture of the domain, and when the domain and range are both all real numbers, there's nothing weird going on. It's an ideal situation. All right, so the last question, I don't actually have a question here because really the equations can range quite a bit. It's about how you use your calculator. And there is one question on the final that requires a graphing calculator. You will not be required to have a graphing calculator for anything else in this course. The question refers to asking about what the maximum, minimum, and zeros of a function are, and it can only be done on a calculator. I should have even been more specific, graphing calculator. What I will do is I already have a handout in Canvas that you'll be able to look at to check this out, how to do that, because there could be a wide variety of calculators. I'll make sure that I hit all the major ones. And if you only buy like a TI-30, so you don't actually own a graphing calculator, there is one online graphing calculator that you will be allowed to use on the final, and you can also use them on the test, but you don't really need them for anything else. That I'll show you how to use it. But also in the problem on the homework, it's the very last problem in this homework section. It's the only one that requires a graphing calculator. But I guess I'll also mention it does boil down to once you graph the question, then you look at the picture and, hopefully it looks something like this. It won't look messy. And then you just answer the questions again.